Today, we're embarking on the most extraordinary journey imaginable, a voyage through 4.5 billion years of planetary history. We'll witness the violent birth of our world, watch continents collide and split apart, meet the first creatures to crawl onto land, stand face to face with the giants that ruled for over 160 million years, and trace the unlikely path that led to us. This is the story of Earth, a biography of the only known inhabited world in the universe. To understand why life flourished here and nowhere else we've yet discovered, we must travel back to a time before oceans, before atmosphere, before the planet itself existed. Our journey begins almost 5 billion years ago in the aftermath of a stellar birth. There is no Earth yet, no blue marble suspended in space, only a newborn star, our sun, surrounded by a vast disk of dust and gas. This cosmic debris field stretches billions of kilometers in every direction, the leftover material from the sun's formation. If we accelerate time, something remarkable happens. Gravity begins pulling dust particles together. They collide, stick, and grow. Tiny grains become pebbles. Pebbles become boulders. Boulders become planetesimals, rocky bodies kilometers across. Over tens of millions of years, these planetesimals collide and merge. The process is violent, chaotic, and ultimately creative. From this cosmic demolition derby, planets emerge. At least 100 protoplanets orbit the young sun, and one of them will become Earth. 4,540,000,000 years ago, our planet exists, but it's unrecognizable. The surface temperature exceeds 1200 degrees Celsius. There is no atmosphere, only carbon dioxide, nitrogen, and water vapor. The landscape consists entirely of molten rock, a global ocean of lava with almost no solid surface. Approach too close and you'd be incinerated instantly, long before asphyxiation from the toxic gases. Earth is a hellish ball of partially molten rock spinning rapidly through space, but this infernal state won't last forever. Something is about to change everything. A planet-sized object named Theia, roughly the size of Mars, hurtles through the inner solar system on a collision course with Earth. It travels at 15 kilometers per second, 20 times faster than a speeding bullet. The gravitational forces between the two worlds begin deforming Earth's surface long before impact. The collision is almost impossible to comprehend. In an instant, both young planets effectively vaporize. The shockwave propagates around the entire globe. Trillions of tons of vaporized rock blast into space, forming a massive debris cloud around the devastated Earth. Both worlds have become molten, their cores merging, their crusts obliterated. But within just 1,000 years, gravity performs another miracle. The orbiting debris coalesces into a ring of fiery dust and rock encircling Earth. Over time, this ring contracts and condenses. A sphere more than 3,000 kilometers in diameter takes shape. We are witnessing the birth of the moon. The newborn moon orbits much closer than it does today. Not 400,000 kilometers away, but only 22,000. Its gravitational pull on the molten Earth is tremendous. As Earth's surface begins to cool and solidify, the sun rises over the horizon. Just 3 hours later, it sets again. The giant impact accelerated Earth's rotation so dramatically that each day lasts only 6 hours. These brief days pass quickly, but Earth changes slowly. To observe the planet's transformation, we must advance millions of years into the future. 3,900,000,000 years ago, Earth faces a new bombardment. Debris left over from the formation of the solar system rains down continuously. Asteroids and comets slam into the young planet at tremendous velocities. Look closely at the meteorites. Inside many of them, tiny crystals resemble grains of salt, the same kind of salt you might sprinkle on food. And trapped within those crystals are microscopic droplets of water. These deadly projectiles carry something Earth desperately needs, the essential ingredient for life. Each individual meteorite contains only small amounts of water, but the bombardment continues for more than 20 million years. Gradually, water accumulates in vast quantities. As the surface continues cooling, liquid water collects in depressions on the newly solidified crust. Puddles become pools. Pools become seas. Seas become oceans. Earth's core remains molten, hot enough to keep the interior partially liquid while the crust solidifies. Every drop of water that will one day fill Earth's oceans, every glass you'll ever drink, every raindrop, every river, all of it may have traveled millions of kilometers through space inside meteorites before arriving here billions of years ago. Earth is beginning to look more familiar now, but it remains a hostile world. Wind speeds exceed those of the most destructive hurricanes in modern times. These megastorms are driven by Earth's rapid rotation and the Moon's proximity. The Moon's gravitational pull creates enormous tides that sweep across the planet's surface. Ocean waves hundreds of meters high circle the globe repeatedly. But over millions of years, the Moon gradually moves away from Earth. The tides diminish. The planet's rotation slows. The violent storms subside. 700 million years after its birth, Earth has become a water world. Oceans cover most of the surface, but something else is appearing. Small volcanic islands emerging from the sea. Molten rock rises through weak points in the ocean floor. When it breaks the surface, lava pours out, cools, and hardens into volcanic islands. Over time, these islands will collide and merge, forming the first continental land masses. On this young Earth, water and land exist. The planet is beginning to resemble the world we call home, but the atmosphere remains toxic. The temperature is extreme. Nothing we know could survive here yet. The meteorite bombardment that began during planetary formation continues, though less intensely. 3,800,000,000 years ago, a new phase of bombardment begins. Something has disturbed the orbits of countless asteroids, sending them toward the inner solar system. These meteorites brought water, but they carry something else equally important. As they dissolve in the oceans, they release minerals, carbon compounds, and simple proteins called amino acids from interstellar space into Earth's waters. Let's descend to the ocean floor, thousands of meters below the surface. Down here, sunlight never penetrates beyond 300 meters. The temperature hovers near freezing. It's pitch black, but something extraordinary appears in the darkness. Structures resembling underwater chimneys rise from the seafloor. They're not emitting smoke, but superheated water. Seawater seeps down through cracks in the oceanic crust. Deep underground, it heats up and dissolves gases and minerals from the surrounding rocks. This chemical-rich mixture shoots back up through the seafloor, depositing minerals that build these chimney-like structures. These are hydrothermal vents. The water emerging from them can exceed 300 degrees Celsius, yet it doesn't boil because of the extreme pressure at this depth. Add the minerals and organic compounds delivered by meteorites, and the ocean has become a complex chemical soup. Somehow, we may never know exactly when or how, these chemicals assembled themselves into something new. Life. The oceans now teem with microscopic single-celled bacteria. These are Earth's first living organisms. This is a defining moment in our planet's biography. For the first time, Earth is inhabited. But then, for hundreds of millions of years, nothing changes. No progress. No evolutionary leaps forward. The only living things remain simple, single-celled bacteria. To find more complex life, we must jump forward to 3.5 billion years ago into the shallow coastal waters. Strange structures dot the seafloor. They look like rocks, or perhaps plants growing upward. They're actually mountains of living bacteria, colonies called stromatolites. These bacteria perform something almost magical. They convert sunlight into food through a process called photosynthesis. This reaction uses sunlight's energy to transform carbon dioxide and water into glucose, a simple sugar similar to what we add to coffee. And during this transformation, a waste product is released: oxygen. Underwater, stromatolites slowly fill the oceans with oxygen. The oxygen reacts with dissolved iron in seawater, creating rust. This rust settles to the ocean floor, forming deposits of iron-rich rock. One day, we'll mine this mineral to build bridges, ships, and skyscrapers. Above the waves, oxygen transforms the atmosphere itself. These stromatolites are creating the single most important ingredient for complex life on Earth. Without them, almost nothing else would exist. Every breath we take happens because of these ancient bacterial colonies. Over the next 2 billion years, oxygen levels continue rising. Earth's rotation slows further. Days lengthen to 16 hours. Building a habitable planet takes time. 500 million years ago, 3 billion years after Earth's formation, there are still no complex organisms, no plants, no dinosaurs, no humans. But Earth possesses something no other known planet has: a force that will change everything. Our planet is a beautiful blue sphere dotted with volcanic islands. 500 million years ago, only simple organisms inhabited these waters. Over millions of years, something is pushing the islands together. Hidden beneath the ocean, Earth's crust has fractured into enormous plates. Even deeper, the planet's core remains hotter than the sun's surface. This extreme heat creates movement in the rock beneath the crust. These movements push and pull the tectonic plates across the globe, carrying oceans and islands with them. As millions of years pass, the planet appears dynamic, changing, almost alive. Over 400 million years, the islands and continents assemble into a new massive supercontinent called Rodinia. In the shallow waters surrounding Rodinia, stromatolites have been performing their magic for more than 2 billion years, pumping oxygen into the atmosphere. The temperature averages 30 degrees Celsius. Days last 18 hours. But this landscape looks more like Mars than modern Earth. To find complex life here, we need to travel further into the future. 750 million years ago, in what will one day become Washington State, an enormous force from deep within the planet tears the crust apart. The world is literally splitting in two. Only one force can do this: heat from the molten core. It stretches and weakens the crust. Year after year, centimeter by centimeter, the great supercontinent Rodinia breaks in half. The massive geological activity spawns countless volcanoes. They pump enormous quantities of carbon dioxide into the atmosphere. Smoke and gas fill the sky everywhere. All this carbon dioxide mixes with water in the atmosphere, creating acid rain. When acid rain falls on exposed rock, the rock absorbs it along with its carbon dioxide. Right now, Earth has vast amounts of exposed rock from the continental breakup. So much rock that huge quantities of carbon dioxide are removed from the atmosphere and locked inside the stone. Without enough carbon dioxide in the atmosphere to trap heat around the planet, temperatures plummet. In just a few thousand years, the global temperature drops to minus 50 degrees Celsius. This is a frozen, lifeless Earth. 650 million years ago, in what will become southern Australia, we're entering what some scientists call the Snowball Earth period, possibly the longest and coldest ice age in planetary history. A massive ice wall rises 1,000 meters high. The ice spreads relentlessly. The more ice forms, the more sunlight reflects back into space, and the faster the ice advances. Another ice sheet of equal height expands from the opposite pole. The two sheets advance from the poles toward the equator, eventually meeting. The entire planet is buried under ice up to 3 kilometers thick. Once a molten fireball, Earth has become a frozen ice ball. Nearly all sunlight and heat reflect back into space. But this cannot last forever. Something must free Earth from its icy prison. Will any organism survive beneath the ice when it ends? The surface is frozen solid, but the core remains hotter than the sun's surface. Volcanic eruptions have continued since the world began freezing, but until now, even their heat and power couldn't affect the ice. The volcanoes pump billions of tons of carbon dioxide into the atmosphere. Before the Great Cooling, exposed rock absorbed most of the carbon dioxide. Now, with all rock encased in ice, nothing can absorb this gas. It accumulates in the atmosphere. Like a blanket, it traps solar heat around the planet. Temperatures rise. After 15 million years of ice, melting finally begins. Scientists believe that during Snowball Earth, the ice's weight pushed the crust downward. Now, as it melts, the crust rebounds, creating fractures and weak points. More and more volcanoes erupt, releasing even more carbon dioxide. These volcanoes drive temperatures higher. The melting accelerates. Oxygen levels spike through a series of chemical reactions. While the planet was frozen, ultraviolet rays reacted with water molecules in the ice, producing an oxygen-rich chemical compound, hydrogen peroxide, the same substance that bleaches hair. As the ice melts, the hydrogen peroxide breaks down, releasing massive amounts of oxygen. Earth awakens, and it's now a completely different place. 600 million years ago, the atmosphere has warmed. It's now like a summer day. Day length approaches 22 hours. Add all this water, and you have the perfect recipe for life. Before Snowball Earth, only simple bacteria existed. Certainly nothing could have survived an ice age 75 times longer than all of human history. If anything survived, the best place to find it is where we last saw life, in the ocean. 540 million years ago, in oxygen-rich waters, those bacteria have evolved. A small number must have survived the Great Freeze. Plants are everywhere, and not just plants. This looks like some kind of shelled mollusk called Wiwaxia. It represents a new generation of complex multicellular organisms. We're entering one of the most dynamic periods in Earth's history, the Cambrian Explosion. Thanks to elevated oxygen levels, living creatures grow larger. They develop skeletal structures. Worms appear, sponges proliferate. And here come trilobites, distant relatives of insects, lobsters, and scorpions. In the oceans, life is thriving. Microscopic bacteria have given way to monsters like Anomalocaris, measuring about 60 centimeters long. Look at its huge eyes, razor-sharp teeth, and grasping appendages. Anomalocaris has only to choose its prey. This is Pangaea, only about 5 centimeters long. It possesses perhaps the first backbone in history. Over millions of years, this simple structure will evolve into the spine that allows us to stand upright. We descended into the ocean expecting to find life struggling in the ruins. Instead, we've discovered a world full of life. Scavenging trilobites, hunting monsters, and creatures taking on familiar forms. Beneath the waves, Tens of thousands of plant and animal species now exist. It seems life's momentum cannot be stopped. We're searching for signs of life on land. 460 million years ago, plate movements have created a new continent, Gondwana. It's warm here. The temperature is 30 degrees Celsius. Oxygen levels approach modern values. Land should be covered with vegetation and teeming with creatures. But there's almost nothing here except scattered patches of algae. There's only one explanation: the sun. It's bombarding the surface with deadly radiation. The complex organisms we saw in the ocean wouldn't stand a chance here. But 50 kilometers above the surface, where solar rays penetrate Earth's atmosphere, something strange happens. When solar radiation strikes oxygen molecules, they transform into another gas called ozone. This gas envelops the planet. The ozone layer absorbs deadly radiation. Over 120 million years, the ozone layer thickens, blocking more and more radiation from reaching the surface. Finally, land becomes safe. 340 million years ago, a remarkable sight appears: plants on land. These are the first forests. They're only a few meters tall, but they represent a revolution. For the first time in Earth's history, complex life exists on land. And wherever plants go, animals follow. Some fish have developed the ability to survive briefly out of water. These lobe-finned fish are our ancestors. One day, their descendants will walk on land permanently. Life is spreading everywhere, in oceans, rivers, swamps, and forests. Earth is transforming into a planet we'd recognize. But planetary forces are still at work. Plate movements continue. Over millions of years, continents drift across the globe, colliding and merging. 250 million years ago, all continental landmasses have assembled into one massive supercontinent, Pangaea. It stretches from pole to pole, encompassing all climate zones. On this supercontinent, life has diversified enormously. Massive forests cover the land. Strange reptiles and amphibians roam the landscape. The world seems poised for even greater biological complexity. But disaster strikes. The Permian extinction, the most catastrophic mass extinction in Earth's history, kills more than 90% of all species. Massive volcanic eruptions in what is now Siberia pump enormous amounts of gas into the atmosphere. Global temperatures soar. Ocean chemistry changes dramatically. Life nearly ends. But life is resilient. From the survivors, new creatures emerge. 230 million years ago, we enter a new era. Small reptiles have evolved into something extraordinary: dinosaurs. For the next 165 million years, these creatures will dominate the planet. They evolve into countless forms: massive herbivores, swift predators, flying pterosaurs. They spread across every continent. They rule the land, the skies, and even venture into the seas. The world of dinosaurs seems eternal. Nothing on Earth challenges their supremacy. Nothing on Earth. A fragment of rock from space is approaching. A large fragment. This asteroid measures about 10 kilometers in diameter, larger than Mount Everest. It's traveling at more than 70,000 kilometers per hour, heading directly toward Earth. It's aimed at the Gulf of Mexico, near the coast of the Yucatan Peninsula. It moves so fast that if we blinked, we'd miss the moment of impact, unless we slow down time. In an instant, the world will change forever. At the moment of impact, the asteroid's trailing edge is still at 11,000 meters altitude, the cruising height of commercial aircraft. The asteroid strikes with such force that it obliterates everything it hits. Even the asteroid itself instantly vaporizes. The energy released equals millions of atomic bombs. There are no safe places. An enormous crater forms instantaneously. Rock, both asteroid and Earth's crust, vaporizes and blasts into the atmosphere. The shockwave radiates outward like shrapnel from an exploding bomb. Within minutes of impact, Earth is under attack from all directions. Boulders the size of city blocks rain down everywhere. Earthquakes shake the ground. Tsunamis devastate coastlines. But the assault has only begun. A jet of vaporized rock and dust spreads across the planet, blocking out the sky. It acts like a giant heat lamp, warming Earth's surface to 275 degrees Celsius. Vegetation spontaneously ignites. Wildfires spread across continents. Then darkness descends. The dust and debris block sunlight. Without light, plants die. Without plants, herbivores starve. Without herbivores, carnivores follow. It's hard to imagine anything surviving such an assault. 65 million years ago, dinosaurs were vaporized, crushed, burned, and starved. Their reign, which lasted 165 million years, ended in catastrophe. But the death of dinosaurs creates opportunity for another group: mammals. Living underground protected them from the heat and fires. They can eat almost anything: plants, insects, carrion. While more specialized creatures perish, mammals survive. These are the unexpected heirs to the dinosaurs' throne. One story ends, another begins. The dinosaurs are gone. Perhaps this is our ancestors' chance. The dinosaurs have been extinct for millions of years. Earth is peaceful. Our mammalian ancestors are evolving. 47 million years ago, at a lake where Germany will one day exist, we should find them. This should be an ideal place to discover mammals. Here's one we haven't seen before. It has large eyes and a relatively large brain. This is Darwinius macillae, nicknamed Ida. Ida doesn't look like us, but the existence of this fossil suggests that these creatures may have given rise to apes, primates, and eventually humans. We're looking backward through 47 million years of evolution. Before us is possibly one of our earliest known ancestors. This lake sits in a volcanic crater. Suddenly, it releases poisonous gas. The gas kills Ida, but the lake that killed her will preserve her in its oxygen-free depths. One day, when the water disappears, Ida will be fossilized. We will discover her and recognize that in this simple primate lies the beginning of our own story, the story of humanity. This is Earth's biography, from a molten ball of rock to a world that gave birth to consciousness itself. A 4.5 billion year journey from dust to us. Every mountain, every ocean, every breath of air, every living thing carries the legacy of this extraordinary planetary history. We exist because of cosmic collisions, volcanic eruptions, ice ages, and catastrophic extinctions. We are the universe's way of understanding itself, the latest chapter in Earth's ongoing biography. And the story continues.